multidisciplinary and cross-platform coordination means that the disciplines we've been working on are road design, which we are going to isolate right now, so that you just see the road design. Road design, great. Then we're gonna go to the drainage, the structure, MEP, and vertical and horizontal signs of the road. We see it right now super tiny, but it's just that you see that all the information is organized related to these disciplines. And then we're gonna explain you how we did it in multiple software platforms. Right now we're gonna go to a section of the model, maybe, but it's gonna be shown better. Here we can see all the disciplines. We've used for them Istrom. We've used also Revit. You see, Mario is clicking and then it gets selected in the model because we have all these searches that can show us what have been modeled in Revit or in Istrom or in Tekla for the metallic structure, or in even Allplan. Okay, let's move back to the presentation just for the bullet point. Data structure. That's a very important part. Let's go back to the model. Let's go back to the model. Okay, so we're gonna go through the project browser. As we were saying, the data structure for us is crucial. You can see here on the browser the nomenclature of the different models that are linked to what we call federated model. You see all these models here that Mario is showing you. It's super important for us, this nomenclature, because it lets us discretize between the software used and the discipline with the acronyms contained in their names. You see, for example, here EST means structure, TKL means Tekla at the end, so you have like all the disciplines and all the softwares that have been used, and all these different models are linked to the main federated model. Okay, now let's talk about, we talk about the models that are linked. Related to data structure, we are gonna move to the relevant parameters of each element that has been modeled. Let's go to the section again, which was super to see that right now. Then we can select different elements and see this relevant data in the IDP parameter tab, which you're gonna see right now. You see here, it's so huge. You see the title, it's called IDP parameter there. We can see all the relevant data in that box there. The information that is shown relates to the codification and chapter of the cost plan. So we see here IDP partida, which would be the line, the cost line, capítulo, which would be the chapter, the ID, and the unit of measure of the element that right now Mario is selecting. That is super relevant information for us, because what happens in most models is that you have all these parameters mixed and you cannot find what you're looking for. So it's super important to have it in one tab so that the client or anybody that is looking at the federated model can find what they are looking for. Okay. Next bullet point, parametric design. Why parametric design makes smart models? Here we can see an example. We don't know if most of you use super technical programming and Dynamo stuff. We were wondering if there would be technical people or more commercial ones, but don't worry, we're gonna explain it to you. We have used Dynamo programming in order to digitally fabricate some of the elements of the model. You can see in the image an example of singular drainage elements. That's the coding we've used to fabricate all the pieces that we need for our model. Okay. Next important word, Open BIM, IFC and BCF. Open BIM formats. We're going to go back to the model right now. We have used Building Smart Open BIM standards, as you can see in the project browser. You see the termination of all these link models are IFC. That's because we've used these standards to work with the federated model. Now we're going to go to a work of drainage. 57, I think we said we were going to look at. We're going to isolate it so that you can see it here. And afterwards, we're going to open that IFC element in a platform to visualize AFC. I think that's BIM Vision. It could be whatever one. Whatever. So now the drainage we've seen in the model, we can see it here, we can open it. IFC, it's a great format. You can see all the dimensions and all the parameters. We've been visualizing before on the federated model. Okay, let's go back to the presentation. Next important point, it's project revision without drawings. The sector is super used, we are all super used to work with drawings, but this time we decided to review all the project without drawings. Let's go to the model. Mario is like, okay, model presentation, come on. So, as we were saying before, maybe I'm in the middle of what he's showing, but in order to review all the project, we have agreed with the client a reporting system to the federated model where we can leave comments attached to different viewpoints. You see here? You see all the, it's called Informe Avertis. So then we have all this codification regarding all the issues that that they have reported for us, and that we needed some correction. So imagine all these issues through emails. How many issues? Do you remember that number? A lot of them? Okay. But instead of going through email and solving with a lot of emails, we decided to do it that way and with comments. So we put all this information to an Excel file, and then we worked with that Excel file, and once everything was done, we just put it in okay here. We sent that federated model back to Avertis, and he said, okay, you're good with it, or repeat it again, whatever needs to be done. Okay, next point, let's go back to the presentation. One last change, I promised. Okay, so how this gets done with customer training, super important, customer training. Because if the customer doesn't know how to do that, he will send you an email. Because that's what he has been doing his entire life. So if you want them to comment on the federated model, you have to train them to do that. So that's what we did on the beginning. So that worked properly well under our point of view. After that presentation, you can ask yourselves to them to see if they think the same as we do. Okay. Next bullet point. Maybe that one is the most interesting one, which is 5D. 5D is the acronym that is used for cost planning in BIM. Here, we did a database approach. Let's go to a small video we have prepared for you to explain what a database approach means. As we said before, all the elements of the model are coded in order to be linked to the cost plan. Right now, we are visualizing the Access database and its relation to the model. When I say Access database, I mean the software, Access. We use Access to put all this information together. Now we see the relation between the parameters that we have in the model and Access. We're looking at the chapter, the budget line, the description, and the unit of measure. If you remember before on the model, that IDP parameters tab that was so relevant are now the columns that we're seeing in Access and the parameters we're seeing in the model at the same time. Are you opening TCQ right now? Oh, okay. So, now let's go to another part of the video we prepared for you, where we can see how we integrated all the information in one database that we after dumped into a cost software, and we can do it to whatever cost software that the client requires. In this case, we use TCQ from ITEC, which I'm sure you all know. So we imported all this access data into TCQ, and now we see the relation with all these lines, cost as partidas, and the information of the model, which needs to be the same, obviously, because it comes from the model. Okay. We're almost done here. Let's talk about CDE and communication platform. What's CDE? It's Common Data Environment. We used a common data environment to put all the information that we needed to work on with the client. And we used a communication platform that Mario is going to show you right now, which is based in BCF, BIM collaboration format from Building Smart. We decided to use BIM Collab, but we could have used any other one because we are using an open BIM standard. Here we are looking at an issue. We use that basically instead of emails to keep traceability of all the issues that have been appearing during the project development, which you know they are a lot. Okay, let's go back to the presentation. I promise it's the last change. Now we're gonna walk through BIM driving, a simulation, so that you can see how it feels to drive this road. That's the road we've been seeing on the model that we see right now through VR, virtual reality, to feel the sense. Mario, I feel like you can even get inside the car, right? To show them how it would be. So you can prove and see all these parameters related to the slope of the road and feel the sense of driving it. Why so important to use these technologies? No, not just because it's fancy and it looks super good in a high screen, in a big screen. Also because you can detect stuff you're not able to detect in drawings or you're not able to detect in the model. You can see if a signal cannot be seen or it's interrupted by another sign. You can see if the velocity is okay for the road. You can feel if it's too wide or not. And it's also super useful to democratize the experience, because it feels like if you don't know how to read drawings, you're not able to see if the road is appropriate or not. We're on flying mode right now, Mario. As we did before with the model, in this virtual reality, we can also see all the different stuff that we were saying before, all these disciplines. Now you're taking them off, drainage, or just the signs, or just the base. Now we're seeing the structure here, so we can select or just review the parts we're interested in virtual reality too. We were so worried that we don't have time to explain it all. We are done right now. So if you have any questions related to the presentation, feel free to ask in Catalan too. Don't worry for that. ¿Teniu alguna pregunta?